Bloom, and this is Geo 4.3a worksheet. Okay, what we're looking at is we want to name two triangles that are congruent by ASA. So first thing is congruence requires us to have at least a side congruent to each other. There aren't any sides provided in this triangle that are congruent to anything in these two triangles. So we will not even consider that. So let's just knock that out right now. Okay. Now it's the other two triangles. So if I'm looking at that, I've got this side and this side. Those are singles, and a double, and a single, and a single. So if I go from JIH and then go KLM, that'll orient my sides together. So I got JIH is congruent to KLM. Okay, and that's by angle, side, angle. This is my angle, a side and an angle, my side, my angle. Now over here, I've got three right triangles. And this one, they've got that right angle and a single, a right angle and a double, and a right angle and a single. Well, the right angle and the double is not going to be considered then. Now this one's not, just right out. And then I consider the two that I have, which, oops, let's undo that. Then I consider the two that I have here, and I've got RTS, and I've got YZX, or I could go TSR and YXZ corresponding pointwise. All right, so I've got to make sure I know what I'm doing and be able to talk about my angle, side, angle. Remember, these two right angles, they're perpendicular lines that make right angles, and right angles are congruent. So remember that perpendicular two-step. Now, when I'm looking at 3 and 4, we're going to be looking at these for, see if you understand this type of section. So you're going to do that on your own. Now, we've got a proof to complete in this next part. So I'm looking over here, and I'm completing proof by filling in the blanks. So I got segment BD perpendicular to segment AC. So BD is perpendicular to AC. So I got two right angles here, BDA, or ADB, excuse me, and CDB. The only reason I changed that is I have this stuff here to talk about those right angles. Now, I've got segment BD bisects angle ABC. ABC is bisected, cut in half by segment BD. So I can talk about this angle here and this angle here being congruent. Then I've also got this angle and this angle over here being congruent because perpendicular lines make right angles and all right angles are congruent. And lastly, I will have BD congruent to itself because of reflexive property. So those are the steps I'm going to be running on this proof. And let's get started. So I got my perpendicular sides and my bisecting. Well, let's take care of our perpendicular sides. Perpendicular sides create right angles. So I got ADB, ADB, and CDB right angles. That's by definition perpendicular lines. Now, those right angles, ADB and CDB, they're congruent to each other because all right angles are congruent. Then I have angle ABD is congruent to angle CBD. Well, ABD and CBD are created by this angle bisector BD. Okay, so by angle bisector, definition of bisector. Now, BD, this green thing here, that's reflexive. It's in both triangles. It's shared side in both triangles. So now I can talk about these two triangles being congruent by angle, side, angle. Okay, and we're good to go. That's our proof. Looking on to the next page, we have four more proofs. And this one, I've got angle K and M. Those are given, K and M. If I can bring that down here. It's not really going real well for me here. And there's M, those are the singles. And then ML and KL are congruent. They tell me that right here in my given. Well, I'm going to write that down, but remember, I'm probably looking at angle, side, angle here because this whole thing looks like a bow tie. So since it looks like a bow tie, I'm looking at angle PLM, okay, angle PLM, and angle JLM. LK being congruent because of vertical angle theorem. So we've got our given and we got vertical angle theorem. Well, gosh, once I get those marked, I've got these two vertical angles, and since they are the second angles, I will mark them with 2 tick marks apiece. 2 arc marks, I guess. So I got tick arcs there, and I got tick arcs here for the singles. I've got side angle side for my 2 triangles. So I have already proved this statement, and I did it by angle side angle. So now, in the next given, I've got parallel lines, and I've got AE congruent to BD, and angle E and D are congruent as well. So let's look these over. I got E and D, they're marked. I got angle E there, and over here I've got angle D. And then I've got my BD and AE are congruent. Well, look, I've got this, these arrowheads. These arrowheads are implying that I have parallel lines. So I have parallel lines here. That's one arrowhead, and this is my other arrowhead right here. And those are parallel lines. So I'm looking at this angle, angle A, being congruent to angle DBC, not because of alternate interiors here though, but this is corresponding angles. Okay, so by corresponding angles, and let's just make sure you see these corresponding angles a little bit better. If I pull this black in here, and those are parallel lines, and I've got this, and try to believe that that is a straight line. This green and this green, they are inside that corresponding angles area, and we're just going to get rid of that black because that's confusing looking. But what it comes down to is that corresponding angles. So I've got the given corresponding angles and angle side angle. So I've got my given going on. And then I have corresponding angles, A and angle DBC. And after I do that, I am looking at these 2 triangles being congruent by angle side angle. Now, in this next one, in number 8, we have perpendicular sides, and these perpendicular sides create right angles, and all right angles are congruent. So we're going to have to do the perpendicular 2-step here. T is the midpoint of segment QS. So if I got T is the midpoint of segment QS, we got to look that over and go, okay, that's going to be the midpoint of segment QS. So if T is the midpoint of QS, I now know that QT here, excuse me, I lost my arrow. QT here and ST here are congruent to each other. So we're going to look that over. So now, with that in mind, we're going to get our given down. So our given's in. All right. Now I'm going to look at this idea of this perpendicular. We're going to take care of this perpendicular 2-step here. Remember these perpendicular lines, PQT and RST, those are right angles created by perpendicular lines. So that's by definition perpendicular lines. So I know Q and S are congruent because all right angles are congruent. So keep in mind what we just did, this section right here is our perpendicular 2-step. Okay, when we're given this section of perpendiculars here, we got 2 steps to talk about our angles being true, congruent. Angle Q and S are right angles, definition perpendicular lines, and then Q and S are congruent because all right angles are congruent. Remember, Q and S are right angles there. Now, after we do that, I'm going to mark these. Just mark them, hey, they're congruent. I know QT, that's the next thing they gave us, and TS have to be congruent because T is the midpoint by definition of midpoint. Oh, I also flip-flopped this idea because QTP and STP are vertical angles, and those are other angles in this. So I got QTP, and I wrote that first. I thought that I wrote that second. So I'm going to make sure that you know that those are vertical angles. So we got those, and then after that, I've got my midpoint definition. But now look at it, I've got angle, side, angle in my diagram, and I can prove those two triangles congruent by angle, side, angle. Now in number 9, this is our last one on this assignment, we are once again looking at parallel lines. Now, normally we would think, oh, parallel lines, alternate interior angles. But the one before that wasn't. It was corresponding. But look at that. These are my parallel lines. And the parallel lines sandwich my angle. And that angle is going to be right here and right here with that transversal. It's not only a transversal, but JG, GJ is reflexive in this. So I'm going to be able to prove this is true. And once I do these two parallel lines and say that this angle is congruent to this angle, I have these two triangles congruent by angle, side, angle. So let's get this on. First thing, gotta write out my given. Then I'm going to talk about reflexive and alternate interiors. So I'm going to do the alternate interiors first. I've got angle FGJ congruent to angle HGJ, FGJ, and just to make sure in case my little cursor isn't flying across your screen, I'm going to do this with this arrow. I've got FGJ going across here, and it's taking forever to get there. And I'm not sure if I'm going to use this one anymore. And I got H. I can get this back, maybe. I have floating things all the way out here. So I have HJG is my other angle. Okay, and I'm going to bring those in because I've marked them. So I'm going to bring those back in. So I've got those here. And wow. Let's see if I can bring them in and have them stay. All right, there they go. And now I've got GJ and JG. Now, keep in mind, if you said GJ is congruent to GJ, I'm fine with it. But I flipped it because in a parallelogram, the order flips. And if you just look at to prove G and J are in flipped positions. So GJ, JG, and that's why I flip it here. So now I've got that reflexive property, and after I do that, I've got my triangles congruent because of angle, side, angle congruence. All right, so that's what I've got there, and hopefully things are going well for you. If you have questions, make sure you seek out enlightenment and ask them, because if you're not actually working on trying to understand the material, you won't learn it. It won't just suddenly come. You gotta make sure you ask questions and clarify what you know and why I did what I did.